Wow! Astronomers just discovered that the solar system is moving way faster than it should. One trusted cosmic speedometer says we're cruising at a normal pace. But a new one says we're racing through space at a speed that should not even be possible if our physics are right. So it seems that either something out there is pulling us, or one of our basic ideas about the universe is seriously wrong. Now, when we move, things in front of us react more than things behind us. For example, if we walk through falling snow, the flakes hit our faces, not the backs of our heads. Ride a bike, and the air pushes harder in front, while the air behind feels calm. The front gets busier, the back gets quieter. That difference alone is enough to tell our brain that we are in motion. In cosmology, this front versus back pattern has a technical name. It's called a kinematic dipole. Astronomers use this principle when they measure how fast our solar system is moving through space. To do this on a cosmic scale, astronomers look at the sky the way we look at the world when we start moving. Only instead of snowflakes or air, they use distant galaxies. These galaxies sit so far away they barely change over billions of years. So they work like tiny markers frozen in place, perfect for spotting the difference between what's in front and what's behind. If the universe is smooth on the biggest scales, you'd expect the number of galaxies in each direction to be about the same. It doesn't really matter where the Milky Way is pointing or how we're spinning. The sky should balance out. But if our solar system is moving, one side might seem a bit more crowded because we're flying into it. It's the same trick as noticing more rain hitting the front of your jacket when you run forward. So, astronomers created huge maps of the sky using radio telescopes, which are good at picking up galaxies that shine in radio waves. Radio waves travel through dust, so the view stays clean. They counted how many radio galaxies appear in every direction to see if one side of the sky really is busier than the rest. And that's when they noticed something strange. The side of the sky we're moving toward was much more crowded than expected, like someone stuffed extra galaxies into that patch. This could mean we're moving faster than the standard model allows, or the galaxies are unevenly spread. We already know our motion from another source, the cosmic microwave background. It's the leftover glow from the Big Bang, and it works like a giant universal speedometer. For decades, it's given us a stable measurement of how fast the universe is moving. But this new result does not match that value at all. That extra crowding in the sky isn't supposed to exist at that level. Our best model of the universe says that when we zoom out far enough, the cosmos should look smooth and even. This result makes scientists scratch their heads. The pattern in the radio galaxy map was much stronger and more lopsided than expected. It lined up almost perfectly with the direction we're already moving, as if something out there was pulling harder than anything we've put into our models. Now, scientists just didn't look at one map and call it a day. They checked the result using several sky surveys made with different kinds of radio telescopes. One of those was LOFAR, a giant web of antennas spread across Europe that listens to the lowest, faintest radio signals, combined with two other large radio surveys. It's like taking 3 pictures of the same scene using 3 totally different cameras. If one of them added a strange color or distortion, the other 2 would catch it. But here, all 3 showed the same odd result. The dipole they measured is about 3.7 times stronger than what the standard model of the universe predicts. That's not a small calibration problem. That's a "your calculator must be broken" kind of difference. To understand how impossible this is, imagine checking 2 speedometers at the same time. One of them is the reliable one we always trust. That's the cosmic microwave background in this situation. It says we're moving at a normal speed. But the second speedometer suddenly claims we're going more than 3 times faster, like 200 miles per hour inside a parking lot. We would know something was off. Both readings can't be right. This is the problem. The CMB gives a solid decades-old speed, but the new radio galaxy result is showing something different. 2 measures that should match are telling very different stories. So what could be the reason for these broken calculations? Well, one idea is that the universe is not as smooth or even on large scales as our model assumes. We expect that if we zoom out far enough, everything should start looking roughly the same. But this result hints that the large-scale universe might be more uneven than that. Maybe some huge regions are a bit richer in galaxies, while others are emptier, and those differences add up across the sky, creating a dipole stronger than the standard model predicts. If that is the case, the extra radio galaxies are not a mistake. They are a sign that the cosmos does not follow the straightforward pattern our model assumes. Now, another idea is that something genuinely huge and nearby might be pulling on our whole region of space. No, sadly, not some giant space monster messing with our system from another dimension. The universe already has giant walls of galaxies, long chains of superclusters, huge clumps of dark matter, and massive empty voids that stretch for hundreds of millions of light-years. These things are so large that they can change how entire regions of space move. It's not a sudden yank, more like a slow, constant tug on everything nearby over a very long time. If there's something like that close enough, we can't see it. A wide stretch of space is hidden behind the Milky Way's own dust and bright stars. Astronomers call this the zone of avoidance because our telescopes can barely look at what sits behind that glowing band. We already know there's a large concentration of mass in that blocked region called the Great Attractor, which was my nickname in high school. And some researchers think something even larger could be sitting deeper in the same direction. Now, if that's true, then the strange pattern we see in radio galaxies might not be a mistake. It could be the first hint that something huge is tugging on our whole galaxy region, and we simply haven't mapped that part of space yet. Finally, the third idea is that something is off with the model we use to describe how the universe works. A model is just a big set of rules, like a recipe. Our current one explains dark matter, dark energy, how galaxies spread out, and how the cosmos changes over time, and it expects the universe to behave in a smooth, predictable way on huge scales. The radio galaxy result does not fit that picture. It behaves like a number that refuses to match the rest of the equation, so scientists have to take it seriously. It could mean that matter and energy spread across space in a way we did not build into the model. That would not break physics. It would just mean the rules need an update. So, what happens next? A bunch of powerful new surveys are coming online, and even though they weren't built specifically to solve the dipole problem, they're going to be extremely useful for checking it. The Square Kilometer Array and the Rubin Observatory are all going to map galaxies in way more detail than the older surveys we use now. With cleaner, deeper data, these instruments may help us determine whether the strong dipole is real or fades away when we look at it with better tools. None of these are special missions made just for this question, but the next round of observations will test it naturally. If this strange motion turns out to be real, then something big is shaping our whole region of space. If it's not, then we just learned something important about how easy it is to fool ourselves with patterns in the sky. Either way, we get one step closer to understanding the universe and its puzzles. Psst, a giant is hiding in the sky. Kipu is the biggest thing we've ever found in the nearby universe. It's been messing with our understanding of the universe for years, and we've just discovered it. Kipu is dense, powerful, and dangerous to ignore. If we don't understand structures like this, we might be reading the universe completely wrong. So, what exactly is it? It's not a solid object like a planet or a star, and it's not a single thing. It's a superstructure, basically an entire region of the universe, a tangled mess of matter spanning a huge amount of space stitched together by gravity. Kipu is made up of an enormous web of galaxies, galaxy clusters or giant groups of galaxies, gas and dark matter. It's like a superhighway, with galaxy clusters being the cities, filaments being the roads, and dark matter being the invisible infrastructure holding it all together. This giant stretches across 1.3 billion light-years. That means if you traveled at the speed of light, it would still take you 1,003,000,000 years just to cross it. Kipu also holds 200 quadrillion solar masses, even though it only takes up 13% of the observable universe. The name Kipu comes from the Incan system of knotted cords used to record things, called quipus. It was like a writing system. In that system, each knot, color, and twist told a story – numbers, taxes, harvests, and so on. So, when astronomers saw this colossal structure in space, long, tangled, and branching like space cords, they named it after this language of knots. Plus, the shape of the space reminded scientists of those threads. There's a long central filament, and the smaller ones are branching off the sides. What's even more fascinating, Kipu isn't alone. When scientists mapped this part of the universe, they found 5 of these massive structures. They aren't just sitting there either. They formed over billions of years through gravity slowly pulling matter together. All told, all those giants hold nearly half of all the galaxy clusters in that region, 30% of all the galaxies, and a quarter of all the matter in the observable universe. The team that found Kipu used a clever trick. They searched for X-rays coming from galaxy clusters. These clusters aren't just full of galaxies, they're also filled with superhot gas. That gas is so hot it glows in X-ray light, which we can't see with our eyes, but special telescopes can. If there's a lot of that X-ray glow, it means there's a huge amount of matter, galaxies, gas, and dark matter all pulled together by gravity. That's where the densest, most crowded areas of the universe are. So, by following the X-ray glow, the scientists could draw a map showing where the biggest cosmic structures like Kipu were hiding. Why does any of this matter? Because these megastructures mess with everything. First of all, they warp the cosmic microwave background, the ancient light left over from the Big Bang. It's a faint glow of light that fills the entire universe. After the Big Bang happened and our world was created, it emitted its very first light and signals that still haven't completely weakened yet. The leftover radiation is still coming to us, even after 13.8 billion years. By studying this ancient light, scientists can learn what the early universe looked like, and Kipu ruins it for us. These megastructures hold so much gravity that they bend and distort this ancient light as it passes through them. That's called the integrated Sachs-Wolf effect. These warps add noise to the original signal, and now it's harder for us to get a proper, clearer understanding of what the baby universe looked like and how it expanded. They also mess with the Hubble constant. The universe is constantly expanding, and the Hubble constant tells us how fast it's growing. In other words, how quickly galaxies are moving apart from each other. But giant things in space, like Kipu, have so much gravity that they pull nearby galaxies toward them, messing up the way those galaxies move. This makes it harder for scientists to measure the universe's true speed of expansion. They can't tell if a galaxy is moving because of the universe growing or just because it's being pulled by something huge nearby. And finally, there's gravitational lensing. Light in space travels constantly, but it doesn't always follow a straight line. If the space gets distorted, like by gravity, then the light traveling through the space will get bent and distorted too. Gravitational lensing is when light from faraway galaxies gets bent because it passes by something supermassive, like Kipu here. That huge gravity pulls on the light, like how a heavy ball can bend a sheet. And since light delivers information to us, literally makes us see what things look like, this bending distorts how we see galaxies. The images of galaxies end up looking stretched, brighter, or we can even find an entire galaxy in the wrong place. It's like looking at our universe through a warped magnifying glass. If we're not careful, we could misread those distortions and get the wrong idea about what our world looks like. Luckily, we didn't just drop these mysterious superstructures out of nowhere. Astronomers suspected that something like that should be out there. They just didn't know for sure. Our best model for the universe is called Lambda CDM. It says, universe started with the Big Bang, is still expanding, and is mostly made of mysterious stuff, dark energy, and cold dark matter, the CDM part. We can't see or touch these things, but we know they exist, because if they didn't, our universe would literally break apart. This model matches what we do see, like galaxies forming, how stars move, and the overall shape of the universe. So even if some puzzle pieces by themselves are still a mystery, they match the actual picture. And this model actually predicted things like Kipu. When scientists ran simulations using that model, they saw similar structures forming, giant cosmic webs of galaxies tied together by gravity. Kipu matched those predictions in real life. This also means that Lambda CDM is matching real life once again, thank heavens. No huge surprises here. But now that we actually found it, it's the largest known structure in the observable universe. There was another giant before Kipu, the Sloan Great Wall. That one was discovered in 2003 and was believed to be one of the largest structures ever found. And it's still an absolute monster. The Sloan Great Wall stretches over 1 billion light-years across. It's called a wall, but it's not like a wall you'd find on Earth. It's also a vast cosmic web, made up of thousands of galaxies and gas connected by dark matter. What makes both Kipu and the Sloan Great Wall so surprising is that they literally seem too big to exist. According to the Lambda CDM model, structures that huge shouldn't be common, especially at the time they formed. How did these giants form so fast in a universe that's supposed to be growing, expanding, and smoothing over time? And if we keep finding more of them, that would be completely insane. It could mean there's something deeper going on in the way our world is built. It's all part of our crazy Copernican journey, a long series of discoveries where we just keep getting humbled by the universe. Every time we find something like this, we realize even more how we're not the center of everything. First, we learned the Earth wasn't the center of the solar system. Then we found that the solar system is just one speck in a galaxy. Now, even galaxy superclusters, which we believe to be the biggest, are being dwarfed by structures like Kipu and the Sloan Great Wall. But also, these structures won't last forever. Kipu is temporary. Over billions of years, gravity will tear it apart, breaking it into smaller pieces. Some parts will collapse into tighter clusters, others will drift apart. Right now, though, it's one of the most important structures in the known universe. It shapes how galaxies form. It bends light, making it super important for us to decipher. It literally messes with our understanding of the cosmos.
The James Webb Telescope, or JWST, is like the ultimate intergalactic paparazzi. It takes pictures of some of the most famous celebrities in the universe. Stars, galaxies, exoplanets, you name it. The James Webb Space Telescope will snap a photo. So if you're a fan of cosmic celebrities, let's take a look at some of these best star-studded photos. The Carina Nebula. The image of the nebula with the beautiful name Carina was published on July 12th. JWST captured a beautiful view of the nebula, located about 7,500 light-years from Earth. Nicknamed the Cosmic Cliffs, it is, in fact, a hotbed of young stars, some of which are several times larger than our Sun. The Carina Nebula is a celestial spectacle located in the southern constellation Carina. It's really huge, approximately 260 light-years across. Massive stars within this nebula are so bright and hot that they create a glowing cloud of gas and dust around them. The Carina Nebula also contains swirling clouds of gas and dust where new stars are being born. The gas collapses under its own weight, becomes hotter and denser, and all this eventually leads to the creation of new stars. However, the Carina Nebula isn't just some peaceful place of star formation. It's the site of some of the most destructive events in the universe, which create massive shockwaves that obliterate everything in their path. Very chaotic and cool. The Stephan's Quintet. This photo was also posted on July 12th. Stephan's Quintet is a visual group of 5 galaxies located at a huge distance from us. About 290 million light-years in the constellation of Pegasus. It's like a cosmic family reunion. All these galaxies are related to each other and interact with each other in some interesting ways. They're pulling and tugging on each other with their gravity, constantly exchanging gas and dust. This interaction is causing some of the galaxies to collide and merge, which can create all sorts of cool effects, like bursts of star formation and supernovae. Thanks to JWST, we were able to see shockwaves, tidal tails, and other amazing details about these galaxies. Their interactions create a stunning sight that we can see in this photo. Jupiter. And here's our old giant friend. This image was published by NASA on August 22nd. Jupiter is the largest planet in our solar system, and it's known for its many moons and its beautiful swirling clouds. But it also has a system of rings, just like Saturn, which are made up of tiny particles of dust that orbit the planet. These rings are much smaller and less visible than Saturn's, but they're still pretty neat. Jupiter also has auroras, which are colorful light displays that occur in the planet's atmosphere. They're caused by charged particles from the solar wind interacting with Jupiter's magnetic field. Just like on Earth, they can be seen near the poles of the planet. But these auroras are much brighter and more intense than ours. We can even see this crazy light show from space. And now, we were finally able to capture this dazzling sight. JWST's photo shows the auroras of Jupiter, its rings, and even two moons, Amalthea and Adrastea. It's amazing how bright and clear they are on this photo. The Cartwheel Galaxy. NASA released this image on August 2nd. This photo shows us the Cartwheel Galaxy and its companions. The Cartwheel Galaxy gets its name from its shape. It kind of looks like a cartwheel, doesn't it? This is a giant swirling mass of stars, gas, and dust, which is located in the depths of space. It's shaped like a pinwheel with long spiral arms. These arms are held together by the gravity of the central region, which is home to a supermassive black hole. But the Cartwheel Galaxy is a bit different from its spiral relatives. It has formed when a smaller galaxy collided with a larger one, creating a shockwave that rippled through the gas and dust. We'll definitely have to visit this galaxy someday. It's sure to be a wild ride. Spiral Galaxy M74. And here comes another spiral galaxy. NASA released this image on July 22nd. JWST had to peer through thick layers of dust and gas to see this beautiful star cluster. M74 belongs to a special class of spiral galaxies known as the Grand Design Galaxy. This means that its spiral arms are noticeable and clearly outlined. All sorts of amazing things are happening inside of spiral galaxies. Supernovas, stars being born in clouds of gas and dust, and many other cosmic wonders. The glowing gas and dust, the bright stars, and the swirling patterns of the spiral arms make them some of the most striking objects in the universe. Well, we can clearly see it on the example of M74. The Tarantula Nebula. This image of the nebula with a creepy name Tarantula was published on September 6th. The photo covers as much as 340 light-years across. This is a huge distance. Thanks to this image, astronomers have discovered new young stars that were previously shrouded in dust. The Tarantula Nebula is located 160,000 light-years away from us, in the Large Magellanic Cloud. It's the largest and brightest star-forming region in the local group, the galaxies nearest our Milky Way. It's named after its shape, which looks like a bit like the legs of a big tarantula. It's a vast region of space, about 1,000 light-years across, and it's home to some of the most massive and luminous stars in the universe. One of the reasons why the Tarantula Nebula is interesting to scientists is its composition. Its composition is close to the region of stars of the cosmic noon, the so-called state of our universe when it was only a few billion years old. At that time, star formation was at its peak. Thanks to the Webb telescope, we can study this galaxy better and find out what our universe was like at its peak. Neptune's rings. This photo was published on September 21st, 2022. In this photo, we can even see 6 small moons next to the planet, with Triton shining brightly in the upper left corner. You didn't think it was the sun, did you? And yep, Neptune has rings too. They're like the ultimate cosmic accessory. They add a touch of glamour and style to the planet. But unlike some earthly bling, these rings are made of small particles of dust rather than diamonds and gold. There are 5 known rings around Neptune: the Gall, Leverrier, Lassell, Arago, and Adam's rings. Scientists think that these are relatively young, much younger than our solar system and much younger than, for example, Uranus's rings. They were probably created when one of Neptune's inner moons got too close to the planet and was torn apart by gravity. We haven't seen Neptune's rings so brightly since Voyager 2 flew past it back in 1989. So this is a great opportunity to take a closer look at these rings. The Pillars of Creation. This photo was published on October 19th. The Pillars of Creation became famous thanks to the Hubble telescope, but this photo is very lush and much more detailed. These columns, located in the Eagle Nebula, are about 5 light-years tall, which is really, really long. And they look like some majestic rock formations, only much more transparent. Just like a typical Hollywood movie set, they're full of action and special effects. They're home to some of the most dramatic processes in the universe. The gas and dust are collapsing under their own gravity, forming clumps that will eventually become stars. The place is full of intense radiation, jets of high-energy particles, and supernovae. It's like a cosmic version of Survivor. And if this wasn't creepy enough, here's another photo published by NASA on October 19th. They shared it right before Halloween. Here, the pillars resemble an eerie hand reaching for something. Brrr. Anyway, all these photos give us a truly awe-inspiring sight. They remind us of the incredible complexity of the universe and the amazing things that are happening even in the darkest and most remote corners of the cosmos. Let's hope that the James Webb Telescope will continue to amaze us in the future.
It's been more than a year since the James Webb Telescope, which had taken over 20 years to complete, was launched. And for such a relatively short time, the ultra-modern and most powerful in history piece of equipment has already made plenty of discoveries. By observing the universe at infrared wavelength, James Webb lets us see things no other telescope has ever shown before. The primary goal of this incredible piece of equipment is to study the formation of galaxies and stars that appeared in the early universe. For example, look at the closest to us stellar nursery, a region of space where new stars get born. NASA has shared an image from James Webb that shows a small star-forming region. If you look at the picture attentively, you'll see jets bursting from infant stars. Around them, different colored clouds of cosmic dust are colliding with one another. The view is mesmerizing. The red dust consists of molecular hydrogen. You can also notice that some stars have something like shadows. Those hint at the creation of what will later become planets. At first sight, the image may seem chaotic, but astronomers claim that it's a relatively small and quiet stellar nursery in comparison to some others. Many young stars there are similar in size to our Sun, or a bit smaller. The photo itself was taken with the help of Webb's near-infrared camera, NIRCam. It's the observatory's primary camera that snaps images of the cosmos in 2 different infrared ranges. Another amazing discovery the Webb telescope has made is smoke molecules in a distant galaxy. It's the first time such molecules have been discovered so far away from our planet. The galaxy in question lies 12.3 billion light-years away from Earth. It most likely formed about 1.5 billion years after the Big Bang. Despite such a huge distance between the galaxy and our planet, scientists have managed to detect chemical compounds found in soot or smoke, and it's quite a big deal since it has pushed the record for detecting similar complex molecules back by around 1 billion years. This study has also confirmed the sheer power of the coolest piece of space equipment of all time. It managed to make this discovery despite the fact that the spectrometer needed for the measurements didn't perform to the fullest after having experienced a sudden and surprising degradation. The James Webb Telescope has also helped to boost our understanding of exoplanets. Those are planets orbiting stars other than our own sun. At the beginning of 2023, the observatory spotted its first exoplanet, LHS 475b. It's located 41 light-years away from Earth and is approximately the same size as our planet. According to NASA, nowadays, James Webb is the only operating telescope capable of categorizing the atmosphere of Earth-sized exoplanets. The research team behind the discovery believes such results underline the precision of the telescope. They hope that it will help us locate many more rocky exoplanets that we might be able to colonize in the future. Even though, at first sight, it may seem that the universe is pretty empty, it's actually a very busy place, and Webb has all the necessary instruments to see all kinds of cosmic events happening out there. Just look at this image of WR 124. It's a star on the cusp of its explosive demise. In the image, the star is about to go supernova. It happens when a star runs out of its fuel and explodes at the end of its life cycle, releasing a giant cloud of space dust and hot gas into space. The star captured by the Webb telescope was at the Wolf-Rayet stage of its life. That's a period when a star is shedding its outer layers before going supernova. The next amazing thing discovered by James Webb is a star-planet hybrid with very strange clouds. This bizarre world, VHS 1256b, is actually a brown dwarf. Those are bigger than planets but too small to classify as stars. They emit some light of their own and are quite hot, but their mass is simply not enough to fuse hydrogen into helium like full-fledged stars do. Space bodies of this kind aren't actually brown. They occur in a wide variety of colors, but those are mostly invisible to the human eye. What we can see is the light they emit, and to us, it appears to be dark orange or magenta. The brown dwarf discovered by the Webb telescope is almost 20 times the size of Jupiter. It orbits 2 red dwarf stars, and to complete one orbit, it needs over 10,000 years. Astronomers first found out about this unusual exoplanet in 2016, but at that time, they didn't classify it as a brown dwarf, and, thus, couldn't explain its puzzling reddish glow. Now, thanks to the James Webb Telescope, they know the space object's origin. Anyway, back to those clouds. As you know, clouds on Earth are made of water vapor, but those on the brown dwarf are different. They seem to be made of sand. It looks like good old sand from Earth, but it's actually not. The clouds are made of tiny particles of silicate. Another recent discovery involves several large galaxies that scientists believe were born not long after the Big Bang. They aren't supposed to be there, and no one expected to find them. But the James Webb Space Telescope has spotted them. These galaxies, as massive as our home Milky Way, are full of mature red stars. Astronomers have analyzed the light coming from them and estimated their age 500 to 700 million years after the Big Bang. It means that they came into being when our universe was very young, almost a baby. But the most bizarre thing about these galaxies is their tremendous size and the age of the stars dwelling there. The data received by the telescope don't coincide with the existing ideas about what the universe looked like and how it evolved in its early years. It also doesn't match the earlier observations made by Hubble. And here, James Webb has captured a distant region of space in unprecedented detail. This section of space is known as Pandora's cluster. In the image, you can see 3 massive clusters of galaxies coming together and forming a megacluster. The combined mass of these clusters acts as a powerful gravitational lens. And thanks to this natural magnification effect, scientists can see other galaxies in the region. Astronomers claim that the most recent image of Pandora's cluster is stronger and deeper than they have ever seen. James Webb has also managed to spot thousands of young stars never seen before in the Tarantula Nebula. This space formation got its nickname because of the appearance of dusty filaments spotted in previous images. It's the biggest star-forming region in the local group, which includes the galaxies nearest to the Milky Way. The Webb telescope's images have helped to shed light on the composition of the Tarantula Nebula. The telescope has also detected protostars, infant stars in the process of gaining mass. Astronomers expect that these protostars will eventually form and shape the nebula further. Among other discoveries made by the James Webb Telescope, you can see the birth of 50 distant stars. Some of them power protoplanetary disks, which might later form solar systems light years away from our own. Here's one more image from James Webb. You can see a supermassive black hole that has a mass of 9 billion suns. It's so ginormous and ancient that scientists are struggling to explain its existence. Astronomers have also discovered a distant ring of dust, rock, and gas that contains a chemical called methylcation. It's known as a molecular building block of life, and it makes most of the organic material on our planet. James Webb helped researchers see powerful sandstorms on a planet 235 trillion miles away. Astronomers were happy to discover this treasure chest of countless tiny sand particles. Now look at this. Do you recognize this image? Those are the so-called pillars of creation. But this new view shows us just how star-speckled that dusty region actually is. You can compare the new photo with the one taken by Hubble in 2014. This is astonishing proof of scientific progress.
The James Webb Space Telescope, an astounding piece of equipment built to outperform the Hubble Space Telescope, has made a terrifying and amazing discovery that might completely change our perception of the universe. It has successfully detected a faint glow coming from a staggering 7 trillion miles away. Can this glow be shining city lights coming from some mysterious extraterrestrial world galaxies away from us? Well, let's start from the beginning. A few years ago, NASA's infrared Spitzer Space Telescope helped us spot a family of 7 rocky exoplanets orbiting the same star. This star is known as TRAPPIST-1, and recently, our new infrared powerhouse, the James Webb Telescope, has measured the temperature of one of those distant worlds. It was a planet called TRAPPIST-1b. Unfortunately, it turned out that this Earth-like planet was totally uninhabitable. Astronomers took James Webb's mid-infrared camera, called MIRI, and looked at the planet's thermal emissions. We can picture the whole process as scientists using heat-sensing Terminator vision. The results were quite disappointing. TRAPPIST-1b turned out to be scorching. Its average temperature was around 450 degrees F. That's as hot as in an oven. Plus, the planet most likely doesn't have any atmosphere. At the same time, this discovery was another record-breaking first for the telescope, which had already produced some newsworthy results by that time. It was the first time researchers detected any form of light emitted by a small and relatively cool exoplanet similar to the rocky planets in our own solar system. No previous telescope had enough sensitivity to measure such dim, mid-infrared light. When 7 TRAPPIST-1 exoplanets were first discovered, the astronomical community was ecstatic. That's because all those faraway worlds were about the size of our home planet and located in their star's habitable zone. It's the region that is just the right distance away from a star for liquid water to exist on a planet's surface. Thus, the planetary system became the best place to look for rocky planets with an atmosphere. But don't get too excited yet. These planets aren't likely to become new worlds for humans to explore, mostly because the TRAPPIST-1 planets are totally out of our reach at the moment. They're just too far away, at a whopping 235 trillion miles away. Their star is also much smaller and redder than our Sun. It's classified as an M-dwarf star. In our home Milky Way galaxy, there are twice as many of such stars as there are stars like the Sun, and they're also twice as likely to have rocky planets orbiting them. It's probably not surprising that astronomers are very interested in such stars. They're the main targets for seeking potentially habitable planets, and it's also way easier and more convenient to observe rocky planets around such smaller stars. But there's a catch. M-dwarfs are more active than our Sun. They frequently flare and spew high-energy rays which are likely to be extremely damaging to planets' atmospheres and any forms of extraterrestrial life. When researchers examined TRAPPIST-1b before, their observations weren't sensitive enough to determine whether this world had an atmosphere, or if it was just a barren rock. But now, we know. The planet is tidally locked to its star, which means that one of its sides always faces the star, while the other is stuck in perpetual darkness. The latest simulations suggest that if this planet had an atmosphere, its temperatures would be much lower since the air would redistribute the heat around both sides of the planet. Unfortunately, the James Webb Telescope recorded much hotter temperatures than needed for such a favorable scenario. It indicates the absence of an atmosphere and knocks the planet off our list of possibly habitable worlds. But the main excitement here isn't actually the features of TRAPPIST-1b. The main takeaway is that James Webb is capable of making such kinds of measurements. It'll help us explore the atmospheres and temperatures of many other distant worlds.
During the recent years, scientists made 2 breakthrough discoveries about our universe. Thanks to new technologies, we've looked into the distant past. And we've learned something that can change our understanding of the universe forever. What are these discoveries and what do they mean to us? Let's find out. Recently, we unveiled the first color image from the James Webb Space Telescope. It's a mind-bending photo capturing thousands of ancient galaxies. This oldest documented light in the history of the universe dates back over 13 billion years. That's just 600 million years after the Big Bang. It's like getting a sneak peek into the universe's baby album. But that was just the beginning. Astronomers were expecting to see some tiny young galaxies. But what they found was a real surprise. Impossibly early, impossibly massive, and all that from just a tiny red dot. The lead author of the study, Ivo Laba, was working at the computer as usual, and suddenly he got 2 numbers. Age, 13 billion years. Weight, 100 billion stars. When he realized what that meant, he nearly spit out his coffee. But that red dot was just the beginning. The next day they found 5 more galaxies just like this. Turns out, these 6 massive galaxies are as old as the Milky Way itself. The entire research team was in disbelief. They were like, wait, what? These guys couldn't be that mature so early in time. Did we make a mistake? But nope. The James Webb Space Telescope, the new cool guy on the space block, just has some serious skills. It can see through dust clouds with its infrared vision and spot galaxies that were previously invisible. Move over Hubble. There's a new stargazer in town. But why is it shaking things up so much? Because this discovery affects our understanding of how galaxies formed. Let's try to explain. A long time ago, 13.8 billion years ago to be precise, our universe was born. It was chilling out for a while, and then it started to form the first galaxies. And these galaxies were full of gas and dust. Eventually, this gas started turning into stars. Some galaxies were more massive and had more stars, and some were lighter and had almost no stars at all. In any case, they all grew gradually. The stars in them were born slowly and smoothly. That's how our current models explain this. But these new observations from the James Webb Space Telescope show an unexpected surprise. Looks like, even in the early universe, our ancient friends had lots of stars. More than what we would ever expect. If that's the case, then these galaxies are like the overachievers of the universe. They skipped the small and gradual growth phase and went straight to being giant universe breakers. According to our current cosmological model, they shouldn't even exist. But they do, so it looks like after the Big Bang, the stars were forming much faster than we thought, which is pretty weird. This could mean that there's something missing in our understanding of the galaxy formation. As you can see, these universe breakers are really living up to their name, causing a potential total consensus among scientists. The universe was like, hey, I'm about to flip cosmology models upside down. But let's not jump to conclusions. There are many theories that could explain these mind-boggling discoveries without breaking the standard model. For example, maybe the light we're seeing isn't coming from stars at all, but from the swirling disks of doom around supermassive black holes. These colossal cosmic beasts can gobble up matter and spit out a dazzling light show. And James Webb Telescope's keen eye is picking up on these enigmatic accretion disks like never before. Or maybe these galaxies could be playing hide-and-seek with us. Maybe there's more to the story that we haven't seen yet. After all, the universe is vast and mysterious, and we've only just begun to scratch the surface. And whoa, we really need to slow down here. Before we even try to explain all this stuff, we need to confirm whether these ancient galaxies really are that old. Although even if they're actually just supermassive black holes, it still shows an astounding change. We'll have to wait about a year to find out. One thing's for sure, the James Webb Space Telescope has definitely taught us a valuable lesson. Expect the unexpected. And this is just the beginning of unexpected. Evolaba's team wasn't the only one who made such a huge breakthrough. There's also a team that claims that they've unlocked the secrets of the universe's past, and that's worth 2 Nobel Prizes. Move over James Webb Space Telescope, because this discovery came from an antenna that's smaller than a fridge and costs less than $5 million. Talk about space bargain hunting! The astronomers caught this signal that showed some surprises. It was coming from the earliest stars of our universe, back in the days when they were just beginning to twinkle. Say hi to our celestial ancestors again. Now, the signal was pretty weird. The temperatures were unusually low, and there was a pronounced wave that left astronomers scratching their heads. What could be causing all this? Well, there's a theory. Dark matter may have been at work, and if that's the case, then we can really be on the verge of a great discovery. Imagine you're looking at the night sky filled with stars, but there's something else there that you can't see. It's like an invisible cloak that covers the entire universe. Scientists call this mysterious stuff dark matter. Dark matter is like the ghost of our world. It doesn't emit, absorb, or reflect any light. We can't see it with telescopes or our eyes. That's why we call it dark matter. But if we can't detect it in any way, how do we know it exists? Because of its gravitational pull. One day we noticed that our understanding of how galaxies were created was incorrect. According to our calculations, they should have been some chaotic gas, but something held them together, turning them into spirals, like some kind of invisible glue. Then we thought, maybe this invisible glue really exists. If the moon was invisible, we would still suspect that it exists somewhere because its gravity affects the tides on Earth. This is also the case with dark matter. Its gravity influences the motion of galaxies and other cosmic objects. In fact, dark matter makes up a huge chunk of the universe, about 27% of it. Moreover, the normal matter we can see, like stars, planets, and galaxies, only make up about 5% of the universe. So even though we can't see dark matter, there's actually more of it in the universe than everything we can see. Scientists are still trying to figure out if dark matter exists and what it can be made of. Some theories suggest that it could be made up of exotic particles that are different from the particles that we're used to. Others think that it might be some kind of weird, undiscovered form of matter that doesn't interact with light at all. Anyway, it's an intriguing mystery, and if we ever confirm the existence of dark matter, our understanding of our world will change forever. So now you can understand why the excitement in the scientific community is palpable. If this discovery is confirmed, then we will get the first real proof of dark matter. This discovery may be even more important than the Big Bang itself because, as astronomers put it, we are made of star stuff, and so we are glimpsing at our origin. But of course, we still have to wait and explore all this in great detail. In science, one should never rush to conclusions. And while scientists study this stuff, we'll be here, on the edge of our seats waiting for the next space blockbuster to unfold. The universe never ceases to amaze us with its wonders. Who knew that such a small and humble antenna could unlock such cosmic secrets? It just goes to show that in the vastness of space, even the tiniest discoveries can have the biggest impact. Keep looking up, and who knows what other cosmic surprises are waiting to be uncovered.